complex. We can convert existing complex AI models into lightweight version so that they can run real-time on edge device and portable devices. So we have many applications so far focusing on industries such as video surveillance, defense, security. So mainly we focus on image and video analysis. One specific industry focus so far is for military telemedicine and remote physiotherapy. So one special case is in the current military veteran and soldier rehabilitation. Basically, there's a need that soldiers and patients need to be transported from one side to another side for physiotherapy facility. Our technology can provide a remote rehabilitation function that they don't have to commute from one side to another side, so that we can save a lot of expense in the military medicine. In the competitor space, our technology is focusing on high level and customized model compression technique. The benefit of such technology is it's a uniquely compressed model, so that once we compress the model, the tools itself can still keep the original performance and with a significant amount of speed up. And existing technology in the market is going to sacrifice accuracy to 5 to 10% drop. So just give you an example of technology advantage that we test our technology of model compression on, for example, pose estimation, face element, face landmark alignment, and we can actually speed up traditional AI model to 10 to 100 times smaller, and the speed up to 10 to 120 times faster. And we can still have a performance gain from 10% to 32%. Currently, we can convert many cloud-based computing techniques to mobile devices, such as image super resolution, segmentation, object detection, face recognition, video understanding, and so on and so forth. We are supported by DoD, by Mass Venture in Massachusetts, by Northeastern University, and by a few other National Science Foundation, for example, and a few other incubator and accelerator. And right now, we already secured several partners and customers, and with some revenues in the last few months. I'm a professor at Northeastern, focusing on AI. I'm also a serial entrepreneur. This is my third company. The previous company got an acquisition and large investment in the history. So technology-wise, here I just want to demonstrate some function we achieved for human movement assessment and pose estimation. So we call it a pathfind. So this can be applied to fitness and remote rehabilitation. Probably you can see the demonstration here. We achieve real-time human pose estimation and landmark tracking on portable devices and edge devices. Traditionally, this can at this level of accuracy, it can only perform on cloud and server. So we achieved the highest prize in the last year international competition for pose estimation. Thank you so much.
Awesome. Thank you, Raymond. Are there any questions from the audience? We'll have a few minutes for Q&A here. If no questions now, there will be plenty of time later on to ask Raymond questions as well. So no pressure either way.
Yep, I will see you in my company booth.
Awesome. Okay, fantastic. We'll just move right along then to our next team. And we have the Crosstalk company next. So Mustafa, sir, are we feel free to take it?
Sure. Are you able to see my screen?
Yep, we can see it.
All right, let's get started. So my name is Mustafa Rahman, and I'm joined by Arif Iqbal. We are from University of Missouri, Kansas City, and we are a semiconductor solution provider. So we develop chips. Our chips are tailored towards performing analytics on data. As you all know that we are going through a data revolution. And along with data revolution, we are seeing tremendous advances in the industry on new algorithms, models, and frameworks. And all these models and frameworks, they vary for the task at hand. For computer vision, you'll see one type of model, one type of data set. And for language translation, you'll see something entirely different. Our hardware solution is a reconfigurable solution that can be adapted or that can perform the task at hand in a reconfigurable manner and deliver the performance that is required. For federal use cases, in a battlefield or in other scenarios, you often have multimodal inputs where from many sensors, whether it's satellite, drones, or ground vehicles, inputs are coming, and you need to do this processing at runtime without delays. This is where our chip can come in and deliver the performance. So, if we talk about Army's mission, Internet of Military Things, where many devices are connected, you need hardware processing power to deliver. Without hardware processing, it would be very difficult to digest all those inputs and make decisions at runtime. This is where we come in, and our chip can be deployed in the battlefield in vehicles, whether it's airborne or ground, or it can be also in the data centers in central command units. The problems that exist right now with the current solution is that there is an unmet demand for faster compute. The traditional hardware uses, Intel CPUs or GPUs. In a GPU, it would take days to do the training, where we want to reduce this time by an order of magnitude and reduce it to hours. Only thing that comes close to our solution is FPGAs, the field programmable gate arrays that are widely used, but they themselves are very inefficient when it comes to data crunching and these large frameworks that are being deployed nowadays. Our value propositions are: we are fast, we are reconfigurable, and we are scalable. Our chips can be as large as something that can be put in racks and racks in data centers. And we can also make it so small that it can be in handheld devices. In the core, what we have is an innovation for virtual connectivity. So if you imagine that 5 persons are standing in a line and person 1 wants to send a message to person 5, because it's a human chain, the message will hop around and ultimately reach person 5. And if they're linked, then any human in the chain can send message to anyone. We borrow this concept and apply to computing cores where everyone is connected to everyone. This eliminates connectivity bottleneck after fabrication. We also employ new novel algorithms for multiplication that saves us on power. So our offerings are: we can make system on chip, a chip that someone can use to put in different form factors. We can also produce accelerator card where our chips can go in, and we can also make custom solution as a server, so it becomes just a plug and play. And we also offer associated software to run our to run most optimized version on our chip. The steps that anyone would follow is that you'd collect data set, you prepare the data, program it, and then use our software to offload that application to the hardware. We have a chip in progress that we are going to fabricate through TSMC in Taiwan in June, and we also have the software interface ready to run computer vision and language processing tasks. Our performance gives us confidence that we can be the differentiator in the market and still perform over the coming years. We are 3 to 5x better in terms of just pure performance, and our power comparison results are 1 order of magnitude better than the rest. This graph shows that we can process 70,000 images if the batch size is 1, and if the batch size is higher, we can process 350,000 images per second. We have an expert team and a set of advisors who gives us advice on a regular basis. The advisors are all industry veterans with 20+ years of experience. They come from various backgrounds, from chip design to software and applications. In terms of the core team, we have also all PhDs that are experts in their relative fields. Our customers and partners, they are very important. For any semiconductor venture, you'll need an ecosystem. We have that in the right place. We have people who can produce a board for us, who can make a server if we need. And we also have companies like InXL that will help us to port large applications at runtime. With that, I stop and I'm open for any questions. Thank you so much.
Fantastic. Thank you, Mustafa sir. Are there any questions from the audience for Crosstalk?
I'd like to ask Crosstalk a question.
Sure.
That was a great presentation. Thank you. And what I wanted to ask you, will your chip be able to work in a GPS denied environment?
Yes, so our chip processes data. If the data is present in the hard disk, we can crunch it. So if the data is not present, then we'll be starving. So whether it's a GPS enabled environment or not, we just need a data set to be present.
Awesome. Any other questions? Don't be shy. For those of you who don't know yet, we have an 8-second rule at Decode where you have to pause for 8 seconds, because typically that's the amount of time it takes folks to think of a question, find their mute button, unmute themselves, and then start asking it. So I will be implementing that for the rest of our session today.
I have a quick question, Jillian.
Go for it.
So you have the customers and partners. Is Qualcomm a customer or are they a partner? And if
Well, yeah, that's a very good question. So we signed an NDA with Qualcomm. They're customers. They're interested in IP. So we follow up with them about our progresses, and then they take it and see if there's a match internally for products.
okay, so do you have any commercial customers at the moment?
No, so we have Wagon. So this is a cloud compute solution provider. We have an agreement with them, and they're ready to test our chip when it comes out.
Thanks.
Awesome. Thanks for the questions. We probably have time for about one more if anyone wants to hop in here really quickly. All right. Thank you, Mustafa sir. We can go ahead and move on to our next team. And again, all of you guys have the opportunity to catch up with Mustafa sir and the Crosstalk team one-on-one at the end here once we transition over to the booths. Next up, we have Jeff from Ellipsa.
Thank you. Let me know when you can see my screen.
Yep, we can see it.
Okay. Hello, everyone. My name is Jeff Kimmel. I'm the co-founder and CEO of Ellipsa, affiliated with NSIN through Northeastern University. And we've built a platform to intelligently monitor all critical assets through predictive maintenance. So across agencies and departments, industrial equipment has become critical to success, and unplanned downtime and operating inefficiencies leads to issues such as unreliable operating availability, increased maintenance costs, logistical breakdowns, and safety concerns. The traditional AI focus to solving this problem has been through predictive maintenance techniques that cater to large moving equipment such as tanks and planes. These require the deployment of complex AI models requiring large amounts of data looking for a very specific problem. And as a result, organizations have been limited to the type of equipment that can be monitored and benefit from AI solutions. With Ellipsa, we employ an AI-based outlier detection approach where we actually teach the system to find what normal behavior looks like to be able to monitor for any abnormalities. This enables real-time asset monitoring of critical assets. The insights can still be tied to a predictive or to a maintenance schedule. However, the value also goes beyond traditional predictive maintenance, being able to be alerted on previously undetected issues and to optimize equipment through AI. In addition to that, this approach makes it possible to monitor a large number of different assets and go beyond the traditional focus. So if a mission requires, say, an F-35 to be airborne, monitoring the plane is obviously critical. However, equipment such as a power generator, SATCOM, or airfield equipment, if those fail as well, it could also lead to grounding. So we focus on the often overlooked operating assets that are equally as critical to the success of a mission. We do this through our AI templates that are user-defined. The user basically is able to define the different data points that he or she is looking to monitor, and then through a single template is able to connect any number of like devices. This approach allows us to monitor fleets of assets and assets of many different types. We bring automated AI capabilities directly to the edge, enabling secure and monitoring directly on the remote device. Our system starts learning from the moment the device is connected and running. And the fact that we can train and infer directly on the device leads to actionable insights in days, not months. So with traditional predictive maintenance, as I mentioned, machine learning models are built to detect a very specific problem. While we could do that exact same approach, our approach of building models to detect any abnormality of any kind allows you to expand beyond what you're able to detect with far less data. Our user-defined AI templates are extendable to any asset type. Our APIs are plug and play, which connects into existing third-party workflows and dashboards. So you're able to gain these insights directly in your existing systems. It's scalable to any number of devices through a single endpoint. There's no code involved in building the machine learning, and the predictions and inference are done directly on the edge. In the commercial space, we've had success on industrial equipment. An example is a ultra-cold freezer company, where they're using Ellipsa to enable proactive remote monitoring of their critical equipment. In a POC with them, we were able to detect 100% of their failures in advance. And our AI insights not only predict the problem, but actually indicate which sensors are driving that decision and that prediction. In the smart environment space, we have a customer where we monitor a series of HVAC units. And in that example, we were able to gain 80% accuracy in predicting a failure in advance, while also being able to predict short-term and long-term power load requirements, as well as predicting the harmful air quality levels. Within the federal space, we see a lot of different use cases within both smart environments and critical equipment. The Ellipsa platform provides a single technology to monitor multiple asset types across agencies and across the government as a whole. I'll stop there for any questions, but I look forward to hopefully discussing further.
Fantastic. Thank you so much, Jeff. We open it up. Oh, it looks like Maxwell is quick with his hand up.
Yeah, sorry. I guess I'll start with my first part to the question. It's how much do you see y'all as being differentiated from digital twin implementations? Yeah, so I'd say I think that in any way a digital twin, we could plug into a digital twin to enhance it. But I think that a lot of our implementations that we've done thus far are real-time monitoring of the data as it's on the machine itself. So I think from the digital twin, it's obviously a separate standalone unit replicating the machine. The real value for us is in monitoring the machine in real time. But with that said, the HVAC example actually takes their data and sends it to what they call a supervisor server, which is almost the equivalent of a real-time digital twin. So in the two examples I gave for the freezer, we're plugged in directly to the device itself. The HVAC is similar to a digital twin. So I think we could do both, but I guess the answer is that we see ourselves more in real-time monitoring of on the devices. Yeah, I guess because sort of my follow-up is the thinking, at least that I've had with digital twins, goes towards part of what you're getting at, but also, because one thing that you mentioned was user-defined being out of limits, whereas, some of the thoughts with digital twins, as you see it used in the field, being able to get that understanding of, where it fails, being able to predict that fail. And as you're building those, the twins for different aspects of an environment, being able to see, hey, what systems outside of ours that as they go down have implications for us. Sort of towards your comment about, the non-operation, when the loss of non-operational assets taking down operational assets. So hopefully that maked sense. I'm sorry that deviated into more of a comment than a question.
No problem. It does make sense. So.
Awesome. It looks like Jeff, you're next with your hand raised.
Yeah. Have you thought of applying this to cybersecurity incident detection, things like real-time monitoring of network traffic, user behavior, server behavior, that sort of thing? And
yeah, I would say definitely, because I mean, if you think about cybersecurity, right, you're looking for anomalies within the behavior of, say, network traffic or other issues. So it's definitely something that we have thought about. To be honest, we haven't come across the opportunity, so as a result, we haven't really gone down that path. But I would say that is definitely an area that the technology could be easily deployed.
Okay, yeah, because there's this, you caught me when you said you baseline normal, because that's always the hardest thing to do with cybersecurity, is baseline normal, because it's so erratic.
Yeah, and the yes, and so you in that particular instance, you really do need to have and this is where our software too, with the no code aspect, puts a lot of reliance on the domain expertise of the user, where we do rely on the domain expertise to understand that you provide it normal to teach it. So there is a some work in that, but it's yes, you are focusing on finding normal, where there are certain types of assets that are so sporadic where it is hard to detect normal. And so that might be a bit more time in terms of how to train it.
Thanks.
Awesome. Love the questions. I'll throw it over to Sean, and then he'll be our last question before we switch to our next team.
Yeah, so hopefully a quick one. With a lot of military assets being disconnected and not having any sort of API, so say a generator, how do you envision integrating with those? Is that something you would partner with somebody with, or they would need to be modified for sensors or an API, that kind of thing?
Yeah, so we do partner with companies already on that. So for our product can be deployed, and this is how we would actually envision it more for government, is the edge offering, where it would have to be installed on a Linux-based system, but we could partner with a controller of sorts that, say, would connect on site to the generator, and then it's all run self-contained. And I think that the ability to do ours in the cloud and the edge is a bit of a differentiator in some ways, but to that point, we would look to deploy to the edge, say, for the generator, but the generator would have to be connecting its data to a partner's hardware that we would deploy on.
Okay, great, thank you.
Awesome. And for anyone else who has questions for Jeff, feel free to stop by his booth at the end of our pitches today.
Yeah, thanks, everyone.
Thank you, Jeff. Next, we have Amit from UberSpark, and he's on the money, ready to go. I love it. Over to you.
Yeah, you're muted, Amit.
Let's see if I can find Amit's.
Yep. Can you hear me now?
We got you now.
Sorry about that. All right, perfect. So good afternoon, everyone. I'm Dr. Amit Vasudevan, a senior computer scientist at Carnegie Mellon University, and the founder and director of UberSpark Technologies, which is a dual-use cybersecurity startup out of CMU. The next few minutes, we will take a 10,000 feet view of our transformative and revolutionary tech, modular provable security, or MPS. Today's critical government cyber infrastructure is composed of multi-domain operations: space, air, land, maritime. They employ commodity, heterogeneous, interconnected computing platforms, or SHIC platforms, and associated software implementations to deliver rapid mission capabilities. Securing your mission against adversaries boils down to securing the myriad of SHIC platform mission software implementations. And this is tough because there are a plethora of components, complex interactions, which make them prone to cyber attacks and render them costly, both in time and in dollars, to secure and certify. This is evidenced by recent GAO reports that found vulnerabilities on satellite and weapon system software implementations, even after they were subject to rigorous testing and security certification. Current state of practice within DoD and government for platform security and certification primarily revolves around testing and runtime isolation. These approaches by design cannot provide complete coverage with respect to a given security property or security certification requirement. Further, there is combinatorial increase in the testing complexity, resulting in increased testing and certification costs when multiple system components are combined. To gain robust yet practical security on today's Chic platform implementations, we need to tick 3 boxes. In addition to being cost-effective and preserving existing functionality, we also need to tick a third and important box: provable security properties. So what does provability buy us? Mathematically backed security properties on software implementations. This means immunity against entire class of cyber attacks on existing mission systems and software implementations against any adversary. That is a very powerful feature and will help the DoD save money, be more agile, and support the warfighter with new capabilities in a rapid and secure manner against inevitable adversaries. Unfortunately, none of the existing solution paradigms, be it either testing or runtime isolation, can provide this today. Enter our solution, Modular Provable Security, or MPS. MPS focuses on incrementally securing the critical execution and communication paths within and across Chic platforms end to end. An example of such a path in a weapon systems could be opening the hatch, firing a missile, ensuring appropriate missile fin control to avoid any errant object except for the target. How do we do this? We identify Chic platforms in the critical path that we want to secure. We protect implementation level components like memory, devices, and CPU state on those platforms with provably secure guards or proxies that we call Uber objects. We incrementally create and embed Uber objects via programmer-friendly libraries within existing software implementations. And finally, we instantiate and anchor these Uber objects at runtime via our patented, formally verified trusted execution environment on each participating platform. And all this is tied together with our patent-pending unique Chic implementation level automated formal reasoning framework, which allows us to thread together security properties of individually verified components, even in the presence of unverified and untrusted system components, end to end. Changing a single verified component only requires recertification of that component, not the entire system. This will help speed up the process of security certification while still being able to deliver rapid and robust mission capabilities at low cost. Our MPS tech has the potential to dramatically increase cybersecurity, especially in safety critical systems, spanning a variety of government and DoD segments, including the Air Force, Army, Navy, DHS, and DOE. Use cases that we see are provably secure sensor and mission processing to protect sensor data integrity and mission functionality, provably secure engine and weapon systems control for secure air, land, and sea vehicles, and finally, provably secure communication paths and data capsules for secure communication and data integrity and privacy for DoD cloud, homeland security systems, smart grids, and ground control stations. Our offerings are along 3 axes: MPS system support to infuse our MPS tech into existing mission software stacks, MPS runtime and development toolchain for developers to weave in MPS into existing DevSecOps pipelines, and finally, MPS-enabled products and mission environments, MPS Linux, MPS FreeRTOS, MPS robotic operating systems, and so on. We are a pre-revenue startup with 8 years of strong R&D roots at Carnegie Mellon University and years of deep expertise in secure and trustworthy systems. Our MPS tech has been supported and funded by NSF, DoD, and NSIN. We are currently looking for DoD or government operational partners and customers for an opportunity to develop pilots to prove out our MPS technology. And I'll stop there. Thanks.
Amit, I think you win the award for finishing exactly at 5 minutes. That was super impressive.
Take that. Thanks.
Fantastic work. We will open up the floor to any questions now. I'm hearing none. I'll give it one more second. Awesome. Okay. Well, did we have a question? Did someone come off mute?
I have a question, actually.
Yeah, go for it.
Yes, for people who are viewing this and who have those kind of links, as Andrew was pointing out, to the relevant segment within DoD or government, as exemplified by some of the use cases that we were talking about. A technology like MPS is so groundbreaking that we need to have some sort of an operational partner so that we can prove this out and actually show them that this is indeed practical and possible. So I guess my my request to those involved here is to be able to visit our booth, ask us some additional questions, and help us kind of make those connections, because we truly do believe that this will set the stage for the next generation of cyber defense. Thanks.
Awesome, thank you, and love the call out to your booth. Definitely go ahead and visit Amit and his team if you have any thoughts for the team or any additional questions later on today. Awesome, thank you so much. Fantastic presentation. And next we will move on to Jason from Minder.
There we go. All right. Thank you all for coming. My name is Jason Radford. I'm with Minder, a new company being spun out of Northeastern University. We work with intelligence, communications, security, and fusion teams to identify disinformation that matters most. If that's what you're interested in, then we want to talk to you. We're just getting started and we're looking for 1 or 2 partners to help us test out our system in the field to get some validation. Now, one of the central problems of combating disinformation is that there's a lot of it. When you don't care about what's true, you get to say whatever you want, and defenders are left playing whack-a-mole with every new fact to be checked. Our solution is to tell you what disinformation is being shared by real people. Most disinformation out there is all light and no heat. It's bots talking to one another, foreign agencies trying to flood the zone. What we really care about are the ones that get past our defenses. It's the disinformation that gets picked up by the people we're looking to defend, the regular Americans. And that's what we do at Minder. We're here to tell you what disinformation real Americans are seeing and what they're engaging with. The way it works is we've matched 1.5 million Twitter users to their real identities on Twitter. And we listen for disinformation coming out of this sample of 1.5 million people. In addition to their matched Twitter handle, we also have their gender, age within a bucket, income level, ethnicity and race, and location. And what we're able to do is put all of this into a dashboard where you can see the top disinformation stories, keywords, and sources being shared. You can drill down by state or demographic group, so you can see what's being shared by older adults in Florida, Hispanics in Texas, or Republicans in Massachusetts. This allows you to focus your efforts on the disinformation that's gaining the most traction and target your counter disinformation campaigns to the demographics you want to reach. The Minder basically operates as a brand watch for disinformation. So we take the same high quality actor behavior content approach to identifying disinformation that you get from the major players like Logically or Graphica, but we combine that with a high quality social data of companies like Brandwatch. Again, real people, real tweets. So you get the signal of what real people are doing. So let's talk about use cases. Skip one, there we go. Say you're a part of a MISO team focused on the Russian-Ukraine conflict. It's been a site of disinformation since at least the invasion of Crimea in 2014. Now we can set up a dashboard that tracks the disinformation that's emerging and how it's changing over time. This allows you to focus your effort on the disinformation that's actually gaining traction. You'll be able to see the results of your counter disinformation strategies as those stories, keywords, or sources become less popular over time. So there we go. Now let's say you're a part of Cyber Command's election security group, monitoring foreign influence in domestic elections. Now each election is its own event, with new disinformation emerging in real time, looking to disrupt the election over the course of just a week or a month. Now we can spin up custom reports and dashboards as conditions change, so you can see what disinformation is gaining traction in near real time. It also allows you to work with local elections officials in media to issue fact checks that address high priority disinformation as it emerges, and work with platforms and, where necessary, law enforcement to confront hostile adversaries. As I mentioned in the beginning, we're looking for our first partner to help us test our technology in the field. And if you're interested, come to our booth. You can also contact me through Northeastern University. We're still in the process of transitioning the technology out, but we can work with you on pilot projects, and you can be our first partner as we come out of the university. And with that, thank you.
Awesome. Thank you, Jason. Happy to open up the floor now if there are any questions.
I've got a quick question.
Yeah, it looks like Sean may have slightly beat you, Salim.
Okay, go ahead, Sean.
I'll send it over to him first.
So at the risk of asking kind of a touchy question, obviously privacy is a very big deal. We're talking about American citizens. Based on your description, did you get, informed consent from folks, or how are you navigating those issues? How do you view them?
Yes. So on our side, we use only public data. So we actually use voter rolls to identify people and connect them to their real Twitter ID. So we're using public data to match people who are behaving under their real identities. So all of the data that we use is above the board. Now, when it comes to providing any information to the federal government, we do that in a aggregated way. We don't provide individual level data about individual level people or individual level tweets, for example, to the government. One of the things that we understand is that in the process of trying to protect domestic audiences, we don't want to step on freedom of speech.
Great, thank you.
Take it away, Salim.
So I was curious, this may be a weird question, because I feel like at some point disinformation is a little bit subjective, right? So is it based on whoever your customer is? So disinformation for that particular person? Because even if we were to take the case of domestic politics, for instance, disinformation for you may not be disinformation for me, or vice versa.
Yeah, the way that we define disinformation is information that's being created to create a false impression of the world. So it's not the same as misinformation, which is untrue statements. So our focus is actually on the source. The people who are creating the information, or the people who are, in most of the cases, of course, it's outlets, proto-generalistic outlets that are creating this information that's meant to create a deceptive view of the world. And that's where we start. It's really source focused in terms of defining disinformation. Once it's out there, though, then we track it in terms of claims. So the claim that vaccines contain chips, for example, that comes from a disinformation source, but then it gets out there and people, real people get to engage with it. So that's how we go about definition.
Thanks.
Mm-hmm. Awesome. Any other questions for Jason? Perfect. Okay, thank you, Jason. For those who would like to talk to Jason in more detail, definitely visit his booth once we're finished up with our pitches. And we have, just so everyone is aware, there's 2 more pitches in this main room before we go into the open booth time. So with that, we'll turn it over. Jason, if you don't mind stopping your share, we'll turn it over to Reza from Iolani to take us away.
Oh, thank you. Hi, my name is Reza Orbani. I'm currently an associate professor with the University of Hawaii with College of Engineering. As part of my job here in the last 15 years, we realized that for the real-time operation, we need to record the data from the fields, and then we need to extract this features from the record, from these records. And then the most challenging part for real-time operation is when we have to put priority on those features in order to make decisions on time for real-time operations. And this problem gets really more difficult when there are a huge amount of data involved for field related operations. So this is an example of an autonomous driving cars. Waymo is trying to merge the highway. As you see, is trying to merge, it fails and has to go back again. What it does is, as an example here, you see that they have lots of sensors on the vehicle where they run an optimization algorithm to estimate the internal state of the car, and then based on that, they make a decision, which in this case is a path to merge the highway. And then other vehicles react in real time and their state changes. And accordingly, you have to make this decision in real time and fast until you basically close the decision loop in order to basically to achieve your goal. This problem is a real problem for the most of our nowadays issues are related to logistics of military equipments or managing a large group of drones for specific missions. So we have done, as part of our work with NSIN, we have done a project with Hickam Air Force Base, where the problem that they have is during the natural disasters, they have to shelter their plane in their hangars, and the hangars space is limited, and they have to make a decision very fast. Otherwise, the operators needs to fly an aircraft from Hawaii, for example, in this case, to California, and return it back, which costs them, each time they do it, it costs them $5 million. So our set of tools enable the fast decision and operation in real time. We built a fast set of fast solvers designed to be for the edge computational applications. We have a set of multimodal summary analytical tools, as well as a machine learning operation pipelines, and also we provide UI and UX specific design for the specific application in mind. And our IPs within our smart multi-tiered security built in as part of our platform. As part of our project with Air Force Hickam, Dr. Coleman, who's Air Force Chief Scientist, visited Aloha Spark, and she suggested to use the technology for mission critical use cases in Pacific theater. And then she envisioned that our product can be can help Air Force position and space assets on different island chains to meet the requirements dealing with fragmented patterns. We teamed up with Revacom, is a large local company in software company in Hawaii, where they work with defense industry, and they have a tremendous expertise in working with defense industry and providing software solutions to them. We submitted an SBIR phase 2 proposal to Air Force, and unfortunately, we got selected for the award, but the Air Force doesn't have funding at this time. So we are looking for other Department of Defense to transfer the or other defense organization to transfer the proposal to them, and if there's any potential funding, so they we can basically transfer that, and they can administer the award to Revacom and University of Hawaii. So my name is Reza Warbani. I will be more than glad to answer any questions that you might have. Thank you.
Awesome. Thank you, Reza. Opening up the floor to any questions.
Hey, Reza, so is I'm assuming there's still a person in the loop on all of these decisions.
Yes, most of the decisions involve a person in the loop, correct? So yes.
So it just comes basically with a suggestion based on some predetermined left and right limits.
Yeah, we run lightweight algorithms on we run the summary analytics on the data, and we run the lightweight algorithms in order to make decisions on the edge computers, and that helps the decision makers to make the decisions. Correct. And perhaps we manage the security within the infrastructure.
Awesome. Any other questions? Great. Okay. Thank you, Reza. With that, we can shift over into our final presentation of the day. So Dr. Bill, I will throw it over to you.
Greetings. I'm Dr. Bill Goodman. I'm the president and CEO of Goodman Technologies, which was started in July of 2016. And I started it 30 days after learning my 13-year-old needed heart surgery and 1 week after being laid off from my job. And in that position, I knew that I couldn't fail. And just like you on the other side of the screen, I know that your mission can't fail. And so what I'm going to introduce you to do today is on disruptive materials for extreme environments. Everything you're going to see is a nano composite to solve your most challenging problems in space, aerospace, defense, and commercial. And on this slide are a number of our use cases. Here we have things like ballistic armor, thermal protection systems for hypersonic flight, shielding against radiation and nuclear environments, space optics, and even CubeSats. And we have worked with system primes as subcontractors to us, Lockheed Martin, Northrop Grumman, current GE Aviation. So I'm going to ask you a couple of questions today. What if you could dramatically improve the performance of your composite materials? What if this improvement paid for itself? How would that help your mission or program of record? So here we have some of our GT Nano, that's our registered trademark, use cases: aircraft and missile structures, ships, ground transportation, turbine blades, spacecraft and CubeSats, drones, electromagnetic and weapons effect shielding, thermal protection systems, hot structures. In the pictures, I show magnification of a composite material, and composites are made in layers. And in between the layers, you don't have any fibers. You have a very weak matrix rich zone. What we do is fortify that zone with carbon nanotubes, and these are highly aligned. In one case that we studied, looking at the GAO reports to Congress, we addressed the F-35 Joint Strike Fighter program. And by addition of our composites, we estimated that we could reduce the amount of scrap, rework, and repair, resulting in a sustainment of $400 million and $1.1 billion over the 50-year life of the program. So there's a lot of value added here. And here's our value added proposition. Our material behaves like a nano Velcro in any composite. It provides multifunctionality, dramatically increasing the strength, the toughness, and many other properties. It's multi-directional. It works both in the plane and out of the plane of the composite, works throughout. And it dramatically reduces the risk for manufacturing and sustainment cost. Here are some examples of data for multiple customers shown on here. We've picked the Navy and NASA, but what you want to notice is the increases are all double and triple % increases in performance when you use our technology in a composite system. We have a fantastic team. We've been award-winning, Flying 40, Defense Innovation. We were hosted at Eureka Park by the United States government at the Consumer Electronics Show. Our growth rate over 5 years has been almost 5,000%. We're ITAR registered. We have a fantastic team. And I've invested almost all the profits of the company on this non-diluted funding back into patents, into setting up a nano laboratory in Reno and human capital. Here's what our GT Reno lab looks like. We have state-of-the-art equipment, 3D scanners, we have Cartesian printers, we have microwave furnaces. Everything is compliant with local, federal, and state governments. So we're perfectly set up to work with the Department of Defense. And finally, I want to leave you with one last question. Does your mission require materials that can survive the most extreme environments? These are space, nuclear, hypersonic, and or deep cryo. How great would it be if we could tailor a material to meet your specific requirements? Ask us how our advanced manufactured nano composite can provide mission assurance for you. And I'm stealing something from Better Call Saul. You better call Goodman. And I'll see you in the booth. Thank you very much. And I will welcome questions at this time.
Love it. Thank you, Dr. Bill. Any questions for the Goodman team?
I just want to say I applaud Decode, the accelerator, and all my fellow companies that have been in the cohort with us.
Thank you. Fantastic. That's a great way to wrap things up. With that, I'll give you guys some logistics for what the rest of the afternoon will look like. Again, thank you again to all the teams for pitching and for all of our audience members for being here today. What will happen now is we will end this Zoom call and you'll go back in Philo, and in the main room, we had the welcome message at the top. Then we had the 3 pitch floors in the middle. And then if you scroll down to the bottom of the page, you'll see each of our 21 companies have their own booth or their own individual room. So you can feel free to pop in and out of those as you desire and talk to the teams one-on-one. Those rooms have all been customized by the companies themselves to have some of their contact information or their 2-pager or ways to schedule a meeting with them. When you navigate into the room, just make sure you scroll to the top. That's where the Zoom line will be if you're interested in speaking with folks directly one-on-one. And then otherwise, before you leave, there is a survey at the very bottom of the homepage as well. So definitely recommend you fill that out so we can improve future events for all of you as well. So I'll hang on this line here for a few minutes if there are any questions. We've renamed the welcome room technical support if you have any questions or confusions while navigating Philo. So feel free to access that if needed or message any of the decoders around. We're happy to help. So again, great job to all of the companies. Thank you for pitching today. Thank you, audience members, and we'll see you in the booths.
Thanks, Julianne.
Hi, Laura. Hi, Dan. Do you guys know where you're going?
I am browsing through this.
Yeah,
Thank you.
You're welcome. You'll hang up this Zoom line and then feel free to pop into the booths.
Thank you.
Yep.
I'm gonna go jump in some booths. I'll see you later, Jillian.
Cool. Sounds good. Hi, Wilbur. We just wrapped our final formal pitch, so feel free to hop to other floors that are still pitching, or you can go visit teams directly one-on-one in their booths.
Gotcha. How to get there? I'm sorry. I'm interested in the teams that are just presented under the cyber banner.
Yep. So this is a cyber room. You can end this Zoom call, and then if you open up Philo and navigate back to the demo day tab, it'll be all the way at the bottom. You'll see all of the different logos and team names.
So you navigate per room.
Yep. So now you'll have the opportunity to meet with folks one-on-one. Yeah, I can provide you with the names of the teams that just pitched if that's helpful.
1, 2, 3, 4, 5, 6. It's 7. It was 7 teams, correct?
Yep, that's correct.
Okay. So so will you guys be distributing like the 2 pages for each team, or do I have to go to each room and say, can you send me a 2-pager? How?
So the rooms will actually have, if they have a 2-pager, the rooms will have them uploaded. So you don't even have to speak to them. You can just click on their room and download their 2-pager if you want. It's similar to this. If like you'll open the room, there will be a Zoom link at the very top if you want to dial into the Zoom and say hi. Otherwise, all of their resources will be in the room, asynchronous, where you can just download them on your own.
Okay, so leave here, and then you said when I leave here, it's going to show me another window.
So you'll leave here. it'll show you this kind of room, and just press demo, go back to the demo day tab, and that's the main homepage.
Very well, appreciate it.
Yeah, thank you. Thanks for joining.
Mhm.